video, we are going to go over two scripts that are going to add functionality to our game. One of them being a smooth camera follow, and the second would be a very simple one-line scene change script. And then we're going to add some audio to the main character's jump as well. And then I'm going to explain how to do animations on enemies that don't have any interactions, they don't have any AI, so they're not going to be affected by the player's presence, but at least they'll be able to move. So what we're going to do first is what I'm going to show you is what we had done last week, which was we had attached the main camera to the player. And when we do that, even though it works, it's not very efficient. It doesn't look good. So, and the reason why is because we have this weird camera switch when we go left and right, and it looks pretty wonky. Also, when you jump, the camera doesn't really follow smoothly. To me, it seems a little bit too static. So what we are going to do is add some bounds so that the camera follows the character at a very specific X, Y, and Z range. And then we're going to ask the camera to follow the character based on not only its position while we're running across the platforms, but also based on time. So we will have a more smoother transition when the camera follows the character. So the first thing that we're going to do in order to make a script, I had already made a folder underscore scripts here, so if you don't have one, make it. And we are going to make a script called camera follow 2D. And you do that by right-clicking, create new C# scripts, and just call it camera follow 2D. I'm going to be naming it something else since I already have the script made, and I would like to follow the code with you. So I'm just going to call it camera scripts for now, but please use camera follow 2D for yours. And I'm going to double click it, and MonoDevelop will open so we can start programming. So in here, in class, I had explained what void start meant, what void update means, and there's also two other functions, two other methods that allow you to add code inside. That should all be in the class notepad on Google Drive, so I'm not going to go over all of that. But what we are going to do is to assign some variables that we need in order to make this camera follow script work. So the first one is going to be a public float called damp time, and I'm gonna set it to be 15. If you don't really know how to what variables mean, chapters 1 through 3 of the Unity C# book that we're reading will explain variables and methods in detail. So if you did not follow in class, if you still have some doubts, that will be a really good resource for you to understand what these things mean. But pretty much a float is just a decimal number. An integer would be a number without a decimal. That's pretty much the difference. And you have to put an F at the end of your decimal number when you declare a float, or else C# won't read it properly. It will pop up as an error. It will say that you're missing, have a syntax error. So the next variable that I'm going to declare is a private variable called vector3. And in class, what I explained a vector3 to be is pretty much a coordinate. So if we go back into Unity and we remove the 2D view, you will see this grid system. And in here, we have this kind of like a compass that allows us to see the Y, X, and the z coordinates. So that's what a vector 3 is. If you would draw a line going down the y-axis and the x and the z, all those three lines that will continuously go on forever are vectors. And all you really need to know is that a vector always has three coordinates. It needs the x, it needs the y, and it needs the z. That declares the position of any object within your game. So this vector 3, which will be a position, if you will, or a position within the line that is continuous between x, y, and z, is going to be called velocity. And it's going to be set to 0. All right. Now, the only important thing that I want to say here about declaring variables is the difference between a public and a private. Setting a public variable will allow any script to be able to access this number. And also, it would allow us to plug in and change this number that we have set in script in editor. So once we finish this entire writing this entire script, when we save it and we look into Unity, I'll be able to show you the public fields that we can access inside the editor, and the private variables that are just not going to be accessible. The next variable that I want to, not a variable, but at this point is a component that I want to set, is going to be a public transform. And transform allows us just to change position. Transform just literally means position. And I'm going to set it to be called target. And what this public position is actually going to be the character, because we want the character to be the target of which the camera is going to be following. The next variable that I'm going to set up is a public boolean. I explained in class that a boolean is like an on and off switch. When it is true, it means it's on, and when it's false, it means it's off. And I'm going to call this boolean bounds. And I will explain this a little bit later when we actually set up the code for bounds. The last two variables that I'm going to declare are two public vector 3s. And one is going to be called min camera position, min camera pause, and the other one is going to be called max camera pause. And what this means is just obviously, because we want to find the maximum height or width that the character will be able to I guess navigate, if you will, and the x-axis and the x, the y, and the z-axis. Okay, so this is really going to affect the bounds that we're going to make. And this is really helpful when you have a lot of empty space in your level that the character or the player doesn't really have to get to. You want to create bounds so that that empty space will not be seen in the camera, and all that the camera can see is actually the level itself, what you're actually going to be interacting with and playing with. Cool. So we are actually not going to use the functionality of void start. So I'm going to go ahead and delete it. We are going to put our functionality in void update. And like it says here in the comments, a void update is called once per frame. So every frame of the game, this code is going to be running continuously. And that's what we want, because the character is going to be running at any point in time throughout the game, right? So you can be holding down whichever arrows to be going left and right. You can be pressing space to jump. So we really need to be able to have the freedom to always change those X, Y, and Z values or rather, because this is a 2D game, we're only going to be changing the X and Y values continuously because we're constantly navigating, walking around. And that's why we call it update once per frame. I'm sorry that my dog is crying in the background. She wants food, but it's not time for her to eat yet. Okay. So what I'm going to do is set up a conditional statement. And this is going to be calling on my target. So if the camera is honing in on my target, who's going to be my little character, we're going to run all this code. And that's going to be pretty much going to be true the entire time because the camera is going to be fixated on the character. So what we're going to call within here is going to be a vector3, and we're going to call it point. And we're going to have that equal to get component camera dot world to viewport point. I'm going to open parentheses here and declare our position. And our position is going to be the target's position. Ooh. Cool. So what this line means is that I'm declaring a line, a coordinate in the line, infinite line, right, of a XYZ, and I'm calling it point, and I'm asking it to get a component within the camera called world to viewport point. And what world to viewport point is the camera's viewport. So the viewport is this white rectangle around that is really much, it's just your camera. It's what the camera can see. That's what the viewport is. So in this line of code, what I'm asking is for the viewport to fixate itself on my target's position, right? And my target is going to be my little character right here. Oops, I opened up a little bit. The next line that I want to declare is another vector3. That's going to be called delta. And delta always relates to time. So what I'm going to ask, what I'm going to do in this line is pretty much subtract the character's position in relevancy to the camera's position. And that's how we're going to be able to get that following to start. And it's going to be target.position, our character's position, minus get component of the camera. It would help if I knew how to spell. Okay. Whoops. Sometimes it auto-completes. And just be careful that you don't auto-complete incorrectly. Viewport to world point. Viewport to world point. Okay, cool. And then we're gonna declare this viewport vector3's position to be a specific range. And we're gonna do that by declaring a new vector3 within that vector. So we're pretty much asking this coordinate to make a new coordinate. And what I'm going to put in is going to be 0.50 on the X, 0.50 on the Y, and then just point Z. And the reason why I'm putting just point Z because it's really irrelevant. We don't need a specific point Z because it's a 2D game. Point Z's are for depth, and that's used in 3D. Oops. And that's used in 3D worlds. So you don't need that. That's why it's just point Z, which pretty much just means whatever coordinates for Z are in your editor. Cool. Now, these two numbers, you're going to be able to change depending on your wants, right? So if you don't like, if the camera to you seems a bit too high on the y-axis and you want the character to be more centered, or you want the character to be lower or higher within the y, the number that you're going to be changing is this one. And if you want it to make those same changes on the z, you're going to be changing this number. So it's really up to you. These are just two arbitrary numbers that I picked that I liked when I was setting this script up. The next thing that I'm going to do is set up another vector 3 called destination. And this point is going to be the character, the transform dot position plus delta. And remember that delta is this entire line that we just wrote. Keep spelling position wrong. So really what we're doing here is we're changing the point of the camera and we're adding this little equation to it. And all these three together, all these three functions are going to work together in order to make that camera follow. So if you're missing one or the other, it won't work. They're all working together to get the effect. The last thing that we're going to do is add some damping to this transition that we made with these three lines. And we're going to do that by setting the transform dot position to be a vector 3 dot smooth damp. And this is just going to give it almost like a little bit of a delay so that the transition between like point A and point B when you're moving around isn't very abrupt. I'm going to add transform dot position, destination, ref velocity. And again, these are all lines and variables that we had already declared. And damp time. All right. And all these three lines are going to allow that camera to follow the character smoothly. The second thing that we're going to do within this script is to add bounds. So again, it's going to be a conditional statement of bounds. And we're pretty much, all we need to do is set transform position to have a minimum and a maximum on all three coordinates. So we're just going to be setting up a minimum and a maximum for the x-axis, the y-axis, and the z-axis. That's all we're going to do. So it will be transform dot position equals new vector 3. And the function that's going to allow us to do this kind of clamping between a minimum and a maximum is actually called mathf.clamp. We're going to clamp the transform dot position in the x, and we're going to make sure that it has a minimum position dot x and a max position dot x. Okay, and since we're declaring a vector 3, remember that we need an x, a y, and a z, right? So I just set up all the things that I needed for my x, and here you can see what it requires. So we're going to add the y, the same exact thing that we have been doing. So math clamp, mathf.clamp, transform position dot y, min camera position dot y again, and max camera position dot y. And now we have to do it one more time for the z. So mathf.clamp, transform position dot z, min camera position dot z, max camera position dot z. And I believe there are two parentheses because we're closing the z's positions, and then we're closing the entire function itself of vector3. That's why we have to. We complete it with a semicolon. And that's it for this script. That's all we need. So I'm gonna hit Control Save to save everything. Go back into Unity, and the script that we just made, again, I called it camera script, but you should have called it camera follow 2D. So these two scripts are identical. So I'm just gonna plug in the camera follow 2D to my camera. Now make sure that the camera is no longer attached to your character. So I'm gonna bring it out, and then I'm going to add the script that we just created into the camera. You just click and drag it. Make sure that you try to drag it underneath the add component button, or else it'll give you this like no sign. We do that. And now, like I said before, all those variables that we had declared public are now accessible in the editor right here. So you actually don't have to go in the script to try to change any of these numbers. You can do it within the editor, which is really convenient. So what we want to do here first is to drag our character into this target range. I'm gonna take my character and bring it over here. And for the bounds, I will explain it in a second how it works, because it'll be a little wonky at first. But I'm gonna hit Control Save, and we're going to hit play and see how that camera follow works. Cool. So now we have a bit of space on the Y, which we did not have before, which is nice, because in a 2D platform, what you really want is for your character to be towards the middle of the camera, because you want to be able to see the platforms above and below you so that you know where you are going. Very nice. So now what I want to add are those bounds. So this is how bounds work. So I'm going to go to the beginning of my platform. You see all this empty space to the left. I don't want my game to start where you could see that empty space, because we don't need it. What I really, really want is for the game to start right about here, where that platform, begins. I want to start it about right there. So creating a bound in the Y and the X, so that my camera starts right here. That's what the bound is for. So I'm gonna go back and I'm gonna check bounds, and that's gonna allow the bounds to be turned on. Now, if I hit play, this is gonna happen, where the bounds that I created are in minimum and maximum of all zeros. And those are not the coordinates that I have for my player, and they're not the coordinates that I have. They are the coordinates for my camera, but not for my player. That's the reason why the camera is not honing into the player. So I want to make sure that my character's positions, coordinates on the X and the Y are the exact same ones that I'm putting into my bound. So I'm going to do that right now. So it's negative 5.63 on the X, and on the Y, it's negative 2.2. And you can be exact too. I think it was 7.2. Cool. I'm gonna hit save. And now when I hit play, I should be able, or not, it did not work. Let's see why it did not work. So make the maximums really big numbers so that you're not bound to a maximum number, because you don't need that right now. Oh, that doesn't work either. All right, so the next thing that I'm going to do to try to see what's going on is by checking that my camera is not clipping on my art. So by doing that, I'm going to go into the 3D mode. I'm going to make sure that my camera is, let's see, it's near enough. All right, let's see if that works. Nope, I don't know what I'm doing wrong. Let's see. Is it the camera? Oh, hold on. Oh, that's the problem. So the position that you actually want is not your character, but is where the camera's position is once the game starts. This is the number that I want, which is actually the same number as the character, isn't it? Oh no, it's not. It's the same number that I have on. Weird. All right, let's turn off the bounds. Let's turn them